Hello, today we'll be talking about animations, React, and how they play together. We won't go into territory of creative coding with very elaborate animations, but which main task is to rather capture user attention. We'll discover how even simpler animations can level up your UI and user experience by showing the continuity in the interface, providing the feedback to user, and we obviously will see how to implement them in React. My name is Oleh. I'm a full stack developer, but I enjoy making pretty things the most, so I mostly work on front end. I have been working with React and JavaScript for 6 years, but currently I'm mostly doing the open source, side projects, and write educational articles for my blog. So why add animations at all? Well, because they are pretty, at least when done in moderation. But you have so many unfixed bugs and unimplemented features, why would you spend your time just making something pretty? Because animations have other uses too. They, for example, help you to mask delays. So some interesting and intricate loader animation will make user perceive loading as faster because they will spend just some time looking at the animation and don't notice how time flies. So your app will look a lot, maybe not a lot, but look a bit faster for the users. Animations help us to show continuity in the interface, and continuity helps user better understand how interface work, how we get from the one state to another, and it essentially makes users think less about how to exactly use the interface, how it works, and makes navigation easier. For example, in the slideshow, animation shows you that indeed this is, by the animation you can understand that those pictures are in sequence because one slides out, another slides in. Also, animation in the same slideshow might indicate for the user that this is last slide, you can't go any further, because without animation you probably will need to either use some alert or message which looks ugly in my opinion, or you just don't do anything at all and leave user a bit confused. And finally, animations allow us to show feedback and draw user attention. Critical alert, which appears with like shaking animation, is definitely a lot more easier to notice that alert just appearing without any animation. And saying shaking animation, for example, can be used in input fields to indicate that its value is invalid and user needs to do something with it. When it comes to animations in React apps, there are essentially two ways to add them. There are CSS animations and animations made with JavaScript. You probably may already made a lot of CSS animations, but they come in two flavors. It's either a transition, where you can select the duration and the timing function and select the target properties. And from there, browser picks up and decides how to animate this element from its current state to target properties. This works quite well for simpler animations, like maybe changing the color of a button on hover or changing the opacity of the element. But if it's not enough, you always can opt into keyframes animation. With keyframes, you can create as many intermediary steps as you want. You can space them out, so you're not animating from A to B, you're animating from A to B to C, then to D, maybe as back to A, because you also can loop the keyframes animations. But even with those tools, CSS animations are somewhat limited. First of all, because CSS animations live separately from components logic. In our case, component logic lives in the JavaScript files, along with markup with the JSX, but styles and animations live separately in CSS files. And so it's not that easy to tightly integrate them, especially if you deal with some kinds of gestures or any more complex animations. CSS animations don't support physics-based animations or transitions. It's mainly Spring and Inertia, and we will talk about them more in one of the further chapters. But just for now, you need to know that if you want to use Spring, you pretty much need to use JavaScript animation. And the last disadvantage, it's really hard to implement and maintain complex animations. You can make really complex animations with keyframes. It's possible, of course, but it quickly becomes very tedious to make any change to somehow edit this animation, and reading it also becomes kind of a challenge. So it doesn't really work for more complex animations. But with even all those downsides, CSS animations have a very big advantage. It's its performance, because CSS animations are at least on the same level of performance as JavaScript animation, and probably for a lot of animations it will be even better. And CSS animations work without JavaScript, and they're loaded separately from JavaScript. With current bundle sizes, or especially in single-page applications, there are a lot of chances that CSS will be loaded quicker, will be parsed quicker, and will be applied quicker than JavaScript bundle. So user will see animations earlier, and even if JavaScript is not enabled. But if CSS animation is not enough, you can always opt into JavaScript animations. JavaScript animations have a lot more data and tools at their disposal. For example, you can use data unavailable to CSS in your animations. For example, you can use cursor position, or maybe data which user input in the form. You can use gestures. You can react to events which happen on the page and orchestrate your animation based on this. And to do all this in performant way, you need to use Web Animations API. It's kind of low-level API, and you probably don't want to use it directly. It's intended more for library developers to build more abstract libraries on top of it, and more user-friendly libraries on top of it. Fortunately, for React alone, I probably think you can find at least 5 animation libraries, so there are no shortage of that. But when it comes to really versatile libraries, I think there are 2 main contenders. That's either JSUP or Framer Motion. JSUP is very powerful and very popular and with a lot of history, but there is huge downside to JSUP. Is not built for React specifically, and for some it might be a huge advantage. If, for example, if you making kind of landing pages where React is not required. But for us, it's a rather disadvantage, because it's possible to integrate with React quite tightly, but you will need to do this work by yourself. And that's not something you probably want to spend your time on. And to use JSUP in commercial projects, you will need to have a subscription which runs for at least $200 a year. Framer Motion, on the other side, is a lot less popular in comparison to JSUP, but it's a very powerful library, and it provides all necessary building blocks to compose your complex animations on top of it. And what's more importantly, it was built as React animation library. It's pretty much stitched to React in terms of integration into component lifecycle, into other React features. And so today we'll be using Framer Motion to code our animations. Any animation is with Framer Motion start with motion component. Motion component is kind of wrapper around other component. It can be like a vanilla HTML component like div or button, or it might be wrapper around your custom component. Framer Motion provides wrappers around vanilla components out of the box, and for custom components you can just pass it to the motion function and it will return you the motion component. Motion components are required to animate, and they integrate with other Framer Motion features which we'll cover today. So how do you animate the component with Framer Motion? You pretty much just add animate property. Its value is an object with target values for properties of this object. So for example, in this code, we set it to scale 2. Framer Motion provides a couple of shorthands for properties, so you can animate any CSS property, and additionally to that, you have a separate properties for scale, rotate, translate X, translate Y, and other properties which otherwise go into CSS transform property. So in this case, React will mount the div element with scale of 1, which is just the default. And then from there, Framer Motion will pick it up and gradually animate the scale to 2. If you want to set the initial value, you can just set it with another prop. And so in this example, React will mount element. Its scale will be 1 still because it's the default. But then right after this, Framer Motion will set it to 0 and then slowly animate it to do. You might look at this and think like, well, I just can do this with CSS. Why do I need a separate library for this? And you will be right, but the functionality of this doesn't end right here. Animate is just ordinary prop for a component, and as in with other props, you can change its value between renders. And frame of motion will just lose it and just animate the element to its latest value. So what you can do, you, for example, can put a piece of state in it. So imagine a progress bar component which probably has some kind of value or progress property which describes like it's how many progress we have here. Without animations, any change will be reflected instantly because the React will render components with new prop, and this will change the layout. With frame of motion, we have just added one line, which will be our animate prop. You can easily make this animated, and you can put any kind of piece of state in the animate. You can make more complex calculation with state, and frame of motion will just accept it and animate it to target values. But it also doesn't end with SVG or is with HTML, because you can also animate SVG elements. You can animate pretty much every color or numerical SVG property. And there is one special which, like the cost-benefit ratio of using it in animations are very high, so I wanted to highlight it. It's path length, which provided by frame of motion and allows you to draw a path, to animate a draw in the path. Now, in our example, it's a simple check mark, but it will work even with more complex paths. You can maybe draw a few paths at the same time, and it's really limited only by your imagination. But what if you don't want to animate based on state? What if you want to react user gestures? Frame of motion supports two kinds of gestures. We have more complex gestures to which you can react with JavaScript. So you can react when, for example, drag gesture. You can react when user starts dragging elements, when user ends dragging element to any movement during this gesture. And you can animate maybe your state, maybe run some animations. But those are kind of complex gestures. We won't cover them in much details in this talk because we probably will run out of time very quickly. But there is a second type of gestures in frame of motion. Those are kind of like state-like gestures. For example, you can tell the frame of motion to animate components to certain properties when user hovers mouse over it, or when element receives focus. You do this by using properties like while hover, while tap, while focus. They set the same object as you would send to animate property, but difference is those properties will be applied only when element enters the state. In our case, it's tap and hover state. And with that, we get to transition. So conceptually, when you animate something, you move value from B or from A, its starting value, to B, value which you want to arrive to. But you can do this in different ways. You can animate elements fast, or you can animate them slowly, or you can change speed during the animation, or maybe you can change speed based on how long the animation you have. How exactly animate values in frame of motion is called transition. And there are three types of transition in frame of motion. It's tween, spring, and inertia. To set a transition, use, well, something wrong with it. To set the transition, you pass it as a transition property to an element. This will set the transition for the whole animation for this element. Or you can pass it as a property to animate object, or maybe while tap object, and this will set it to be applied only to this particular animation. So let's dive a bit deeper into each type of the animation and when would you want to use it. We start with tween. Tween is a direction-based animation, and that's what is available to you in CSS. So to define clean animation, you define its duration and its easing. Easing describes how speed of the animation changes over time. The basic one you can get is linear animation, which has a constant speed, but its disadvantage is that it looks very boring and kind of robotic. A lot of times in the interfaces you don't really want to use linear animation. You want to use something non-linear, like for example, here we have is in out cubic function, and it just looks more entertaining for the user, and it looks actually more natural, even if the user can't actually pinpoint the difference in quick animations. Frame of motion supports all kinds of easings. It has a lot of easing built in, but you can also provide your own easings. For example, you can take any easing from this website, whichever you like, and put it into the animation. Or you can provide easing as a custom JavaScript function. And so you can use any advanced math you want, you can use any third-party libraries in this easing function and tune it out to be like just what you want and just what you need for this particular task. Next type is Spring. Spring, at least like canonically, not defined by its duration, but is defined by properties of physical spring. Its stiffness, its mass, and its damping. Based on those parameters, frame of motion will kind of simulate the spring and animate value based on behavior of this simulated spring. Those parameters are unfortunately not very easy to understand, or rather easy to get the good parameters on top of your head. So I really recommend you play with some kind of visualizer for spring in frame of motion. It will allow you to better understand which every parameter does, and it will allow you to easier find optimal parameters for your animation. Or alternatively, there is an alternative way to set a spring animation, which async frame of motion borrowed from Apple's Swift UI. You can set spring's duration and bounciness, so how bouncy you want it to be. And based on this, frame of motion will find the suitable stiffness, damping, and mass, and then use those to simulate a spring. And the last transition type is inertia. This is one is a bit obscure because I don't see it used often, because usually in animations you want to animate from A to B, but inertia doesn't do this. Inertia is used to gradually slow down the motion which you already have. So where would you want to use each transition type? Let's start with easy one, inertia. You probably want to use inertia if you already have some kind of movement and you just want to stop it without like looking at it very sudden, just gradually stop it. Easy example from frame of motion itself will be dragging event. So when user in frame of motion, when user drags the element and then let it go, it won't stop just right there where user releases the mouse. It will continue moving, gradually slowing down until it stops completely. And so that's what inertia does. When it comes to spring and twin, I would use spring for pretty much everything, unless you have some, unless you actually need twin and you know this, because springs work really well. They look very natural and pleasant to the eye, especially with properties which are related to a movement or the size of the object. So, for example, translate X and translate Y properties, scale and rotate works especially well with spring animations. But if you are animating something simpler like opacity or background color, twin tends to work just as fine as spring, so you can use it. It might be a bit easier to set up because you don't need to play with 3 separate parameters. And in some special cases, you actually need your animations to look robotic and kind of linear. That's when you reach for twin with linear easing. Frame of motion also makes it easy to animate keyframes. All we covered so far was kind of what you would do with transition in CSS. But it's easy to make a keyframes too. All you need to do is just pass an array of values instead of single value. And frame of motion will animate from one to another and also can look the keyframe animation. As with CSS keyframes animations, I wouldn't make like some complex animation sequences with keyframes in frame of motion because it's still not very convenient and still will quickly become unmaintainable. But if you have some kind of smaller animation, for example, the simple loader animation, that's when keyframes animation work best. Another example of keyframe animation, or where you would use it, is shake animation, which we mentioned in the intro. You would also use keyframes to build it. And with that, we actually get to very cool frame of motion features, starting with exit animations. Frame of motion allows you to animate element after it was unmounted from React's component tree. You can do this yourself probably, but it's not very easy and requires a lot of boilerplate code to handle this. And fortunately for us, we don't need to do this because frame of motion does this for us. But it also requires a bit of setup from our side. First of all, you need to define your exit animation. In our case, it's just the opacity gradually going to 0. And secondly, you need to wrap your element, which will be mounted or unmounted, in animate presence. It's required, so animate presence will keep track of its children and see when it gets unmounted, it will actually run the animations. There is a small pitfall with this because how React works, element has control only over its direct children, so it can't really control nested components. So animate presence can keep track if its direct children gets unmounted, but if it's some of nested elements, animate presence doesn't know about this. And so in this case, exit animation won't work, and you will need to refactor your code a bit to move animate presence a bit down towards component tree. So where would you use exit animations? In a lot of cases, actually, I feel a bit disoriented and lost when some element disappears from the page unexpectedly. If one thinks if element disappears after you put maybe a close button, but if it disappears on itself, I just feel a bit lost, especially when I didn't see which exactly element disappeared and you just notice the layout shift. It feels especially confusing. Exit animations help us avoid this. Even those few hundred milliseconds will be enough for the user to actually see the element, understand that, oh, okay, this element is disappearing, so it will be gone in a moment. Layout will shift a bit, and it just helps you to show continuity and helps user to better understand how your interface works and how to navigate it and what to expect out of it. And with that, we finish with our basic features, and you might be tempted to start adding animations to your project. But as with just any coding, you risk to quickly find yourself in a code mess if you don't prepare for it. And especially if you use the same animation a lot, you find that you use it in a lot of places. So why won't we refactor it into a separate variable instead of copying the object every time? Just let's pass this variable defining our animation. Frame of motion takes it a bit further and provides a built-in mechanism to reuse animations. It's called variants. Variants is essentially just an object where keys are names of this name of the variant. And its value is either an object which describes the animation or the function, which in turn still returns the object which describes the animation. And you pass this variance to the component as a variance prop. Every motion component which has its variance defined allows you to use string instead of object into the properties like initial or animate or exit or while hover. And frame of motion will just pick the variant by its name. If you need a bit more of customization, you can pass a custom property to your component. This can be any string, any object. FrameMotion doesn't really work with it directly, but it will pass this object to variants if it defined as a function. So in our example, you can see the highlight variant returns different object depending on type. And so in our case, custom set to danger, and the string danger will be passed to this variant. And so we will get animation with red background color instead of default gray one. Next feature is layout animations. You already know that you can animate pretty much every numerical or color property, but layout animations take it to level further because they allow you to animate any layout change. This layout change may happen because parent element, for example, justify content property changed, or order of element changed, and so they are a bit shuffled, their position changed. Just by adding a layout property to your motion element, you can automatically animate its position and size changes. These techniques, sometimes I think even in documentation, is called as like a magic of frame of motion, but it's not a magic at all. It's just a clever engineering. It uses a flip technique. I won't bore you with huge technical explanation, but if you want to dive deeper, there will be a resource which describes it in great details with great examples. So if you want to dive deeper, I will just check out the resources which will be in the end of this presentation. So where would you want to use layout animations? If you take the cost-benefit ratio into account, the easiest one to pull will be probably animate list order changes. So just imagine if you have some kind of to-do application where you can change the sorting by, for example, by date or by priority. And when users clicks to button to change sorting, without animations, task will just change their position in a moment. User still expects this action because he was the one who clicks this button, but it still might feel a bit confusing because, especially if you have a lot of tasks, everything just changes so suddenly. Just by passing a layout property to your task component, you can automatically animate the changes, and so for user it is a bit easier to understand where each particular task went, and it again shows the continuity, helps to show the continuity, and for the user it just makes it easier to navigate your interface. And frame of motion also supports the shared layout animations. They work a bit differently. In normal layout animation, we animate the changes of size or position of one particular element. With shared layout animations, we can morph one component into another one. And what you need to do for this is to have motion component with layout ID property which sets some unique string ID. And if after some time, frame of motion will see that, okay, we have just another element with same layout ID string just appeared. So frame of motion will animate from the element which was there previously to the element which was just rendered. And so, well, technically it's still two separate elements. For the user, it will see more like one element just morphed into another one. For example, this fill menu is really easy to implement with shared layout animations. Without animations in this kind of component, this gray background will be probably just additional styles on the active button. But for shared layout animations, it's actually a separate element which gets rendered only for the active button. So when active button changes, there is a new gray fill rendered. And frame of motion notices because it has the same layout ID as other fields and animates it from one position to another one, accommodating its any required size changes. So layout animations and shared layout animations are very powerful, but they come with a kind of big disadvantage is to animate those changes, frame of motion uses properties like scale and translate. It's good because they are very performant and they don't require recalculation of layout. So you can animate a lot of objects without huge hit on performance. But the huge downside to this is that if element between renders or different elements with shared layout animations have different aspect ratios, content will be distorted because it will be squeezed for either horizontally or vertically. And it looks especially nicely if the content is text because it gets very distorted and not pleasant to watch. There are different workarounds how you can get around this, but they all really depend on your particular use case. In some cases, you can hide the content while layout animation is performing. So once it starts, you hide the content. When it finishes, you animate the content appearance back. And since those animations tend to be very quickly, in like terms of a few hundred milliseconds, it's not really noticeable for users that content disappeared, but the distortion will be noticeable. So it's kind of trade-off. And in some cases, you can get away with using nested layout animations if it works for your use case. FrameMotion knows how to optimize those nested layout animations. And for example, you could disable text layout. You could disable tracking of size for text elements only their position, so they don't get squeezed, but they still will animate to their new place on page. And with that, we finally get to my favorite part, it's motion values. Motion values as a concept are very simple. It's just a value which you can animate and which you can subscribe to changes. But what it makes them really powerful is their integration with other FrameMotion features. For example, if you pass a motion value to style property of motion element, FrameMotion will look for changes in this motion value and update the style every time the value changes without rendering the whole component. So in our example, when we click move forward, this black dot moves, but it does so without rendering the component. And so we can make a lot of updates, for example, around 60 updates a second, and it will all run smoothly without overloading our browser. You can derive motion values from other motion values. Those will be recalculated every time one of the original motion value changes. And of course, you can use derived motion value just as any motion value in styles and in different more advanced FrameMotion features. You can react to changes of motion value. For example, you might want to flip maybe some state or show some message when value gets past certain point. That's when you use motion value event hook. It can react to changes of motion value, and it can also react to animation start and animation end events for motion value. But what's more important, you can animate motion value. As you saw from the first example, when we clicked move forward, button moved instantly because we didn't animate a change, we just set it for the fixed value. By using animate function, you can animate motion values, and FrameMotion will update the element every time this value changes. So essentially, we'll also animate our div element, our dot, which uses those motion values. And this allows you to build very complex animations and very interactive animations. Alternatively to animate function, though, you can use useSpring hook. This hook accepts a motion value and returns the other motion value with Spring animation attached to it. So every time the original motion value changes, this hook will animate this change into a Spring version of motion value. And so it works nicely when you have motion value change frequently because Spring transitions allow to transfer velocity from previous animation to the latest one. And so it looks very natural if you have some kind of element which moves frequently, which moves in different directions. So where you would want to use motion values, First of all, in complex animation and animation sequences, especially if you want your animations to be interruptible, if you want, maybe will need to pause them sometime or reset, motion values work really well here and makes coding a lot more easier. They're also very convenient if you have animation which depends on user gestures. I know we skipped the dragging and punch gestures from the frame of motion today, but they are very convenient if you have those kinds of animations that depends on user gestures. And they are very convenient if you need to sync your animation between different components. In this case, you will create a single motion value on the parent component and then pass it to children's, which will synchronize those animations. So, for example, this widget is resizable, and it does so without actually re-rendering, because if we use the React state for the width and height, it will work, but it probably will quickly become a performance mess, because if user moves their mouse really quickly, it will result in a lot of re-renders, and React is probably will make a noticeable hit on performance. But here we use motion values, so browser still needs to recalculate layout because we use a width and height instead of translate and scale. But without involving React in this section, we are able to get a lot more performance from this just by using motion value instead of state. And you, for example, can also make animation like this with motion values. It's easy to animate the movement, animate the kind of physics of the objects. And motion values also used in scroll animations. In frame of motion, main way to react to scroll changes is to use this use scroll hook. This hook will return a bunch of different motion values which correspond to the absolute position of the scroll, so how many pixels from the top user scroll, to the relative scroll progress, so value between 0 being not scroll at all, and 1, which means the user scroll page all the way down. And you can also measure a scroll of particular elements, so you're not limited to using viewport. For example, with these hooks, you can transform your scroll progress into width, which then will be used in reading progress indicator, something like this. Every time user scrolls, the width gets updated, but still without re-rendering the whole component. So from the performance standpoint, it's a lot better than using state for this. And another common use of scroll animations is to run the object appear animation once user scrolls to it, so user actually sees the appear animation. To do this in frame of motion, there is a property similar to gesture property. It's called while in view, and it accepts the object same as the animate prop or while cut property, and it runs this animation only when element gets into the viewport, so user will see it. With that, we are done with our crash course, but I have also a couple of cool components which just didn't get into the other chapters, and so I will show them and I will tell how to. I will tell you how you can do this. This component uses a short layout animation, so you can see as how card morphs into a model. But if you look closely, you see that text didn't get distorted. That's where we use nested layout animations, because frame of motion can animate size or position change or both of an element. And for the card model, we animate both, so we see the position and side change. But for text, we animate only position, and so it just doesn't get distorted while animating. Another example will be this auto-resizable panel, which automatically changes the size to accommodate its content. You might think that it's also a layout animation, but no. In this case, it's a bit different. It uses motion values, and it's composed of two elements. So you have the outer elements, which is the panel or model itself, and it has overflow hidden, because we'll be manually controlling its haste, and so we don't need anything to stick out of it. And the second nested element is a wrapper for a content. And this wrapper will change its size depending on how much text or other content we have here. So we can measure the size and react to the size changes using the resize of server. And every time the size changes, those changes are instant. As you can see, adding or removing text happens in the instant. But when we detect a change, we can run the animation for the height of panel. So while text appears and disappears instantly, haste with changes gradually. And the last, and my favorite for those, is the counter. It's really easy to pull because all you need is use motion value as a content of element instead of using it maybe in style or in other properties, because frame of motion also can set a motion value as a content of element, and it will change the content every time motion value changes without rendering the component. So using this technique, we can animate our metric, and so you will see this numbers animation without rendering component hundreds times just to change its value. And just all you need to do besides this is just add some animation for the color to indicate the direction of metric change, and maybe some arrows. It's like really easy to pull, and all the examples I showed today with source code will be included in the resources link, so you can check them, you can play with them, but just like imagine how it will look in some kind of internal dashboard. And with that, thank you very much for attending today. By this link and the QR code, you will find the resources, including the examples I was showing today. And I believe this presentation will be published on the Meetup page, so you don't need to take pictures of it. If you have any questions, I will be happy to answer them. And thanks again for listening.
If I may, how does it handle, or do you need to do anything specific? If, for example, there's a chance you can start like one animation multiple times before the first one, let's say, finished. Let's say you click a button 3 times, so start an animation, then you click again, and it doesn't handle it gracefully. Do you need to do anything special?
It depends how you run the animation. If you use the animate property or like the similar property, frame of motion will take care of it yourself. So if a value updates, frame of motion will start previous animation and animate to the new value. If you run your animations manually, we didn't cover it in a presentation, but you can run your animation manually, just as you do for motion values. You can do so for elements directly. And in this case, I believe you need to stop your previous animation, because otherwise there might be conflicting animation running for the element. It's not the case with motion values, because motion values can have only a single animation attached to it, so frame of motion kind of take care of that. But if you animate element directly, you need to store the controls object, which will be returned as a result of your previous animation, and stop the animation manually. And you can use the same control object to track the progress of animation, then maybe pause it instead of stopping it, and so on.
And one more question.
Yeah.